What we're going to be doing today is taking that information we learned about why we have seasons and putting that into more of a picture format. So you have two diagrams, one that says Northern Hemisphere, one that says Southern Hemisphere. They look very much the same. Be sure you're on the right page. And you also have a list of things to label on those diagrams. You should have one colored pencil, preferably a yellow or an orange. Unfortunately, I only have red on the smartboard, so that is what I will be using today. Let's start with the picture for the Northern Hemisphere. The directions say label the following things on each globe of the Northern Hemisphere diagram. First, it says to label the equator. So take even just your regular pencil, and we're going to label the equator. Hopefully you know that the equator is the line that cuts the Earth in half from top to bottom. And we should label it on each of our pictures. I'm just going to label it with an E on the rest of them because it's a little bit harder for me to label things on the smartboard than it is for you to label them on your paper. The next thing that we are to label is the Tropic of Cancer and the Tropic of Capricorn. These are two latitude lines that signify the start and the end of the tropics. So we need to know which one is which, and it's pretty easy because they go in alphabetical order from north to south. So the Tropic of Cancer is the one that is that little dotted line above the equator. The Tropic of Capricorn is the one that is under the equator. And again, I'm going to abbreviate on the rest of these. It's harder for me to label things on the smartboard than it is for you to label things on your paper. So we have the Tropic of Cancer and the Tropic of Capricorn on each globe. And again, those signify the upper and the lower boundary of the tropics. Number 4 and 5 label the Arctic Circle and the Antarctic Circle. The Arctic Circle is the one at the North Pole, and the Antarctic Circle is the one at the South Pole. And for my abbreviations on these, I'm going to use AR and AN. Number 6, color the circle of illumination yellow. Number 6 is intended for you to color the area that is lit up by the sun. And so we will start with the ones that are off to the left and to the right first. Those are the easiest to determine. So if you look at the sun shining on the Earth, we kind of did this with our moon phases notes. We could draw a line straight up and down the middle of the Earth, and then everything that is on the sun side at that particular moment would be lit up. Everything that is on the other side would be dark. So that would be, we would have day on the right and we would have nighttime on the left. Go ahead and do the other side. Think about what half is being lit up and what half is having night. And now for the ones that are on the top and on the bottom, you need to try to imagine this picture in 3D. So try to imagine taking the bottom globe and pulling it out so it's in front of the sun, and taking the top globe and pushing it back so it's behind the sun. If you can imagine that, the sun's light would be shining directly on that face, so the top globe is all lit up from what we can see. And then the bottom globe would be shining behind, or on the side that would be like away from us from where we are right now. So we are not going to shade anything on the bottom globe. It does, however, hit directly on the equator in both places. We could put a little X right there. That's where the most direct rays would hit, although it's still on the back of that globe. Okay, number 7, place an X on the point where the most direct rays hit. We kind of just did that. We've got one for this globe, we've got one for this globe. The most direct rays would be about here. And this one's kind of in the way of my writing, but it'd be about there. Okay, number 8. Each season the northern hemisphere would be in at that point. So we need to label the seasons. So you have to think about whether the northern hemisphere is tilted towards or away or neither at those spots. Let's start with the easiest one to see. If we start with this globe here, here's the northern hemisphere, everything above the equator. Hopefully you can tell that that is tilted towards the sun. So this would be summer in the northern hemisphere. Now if we go to the opposite side, here's the northern hemisphere, everything above the equator. Hopefully you can see that that is tilted away from the sun. So this is winter. And now we got to decide about the other two. On the other two pictures, it's really not tilted towards or away because the direct rays hit right on the equator. So of course those have to be our spring and our fall. Which one is which? Look at the way the arrows go. When you have summer and you are going to winter, what season falls in between? Falls. So this is fall down here. And then same thing for the top. When you are at winter and you're going to summer, the season that would be in between would be spring. Number 9. Label the date that would correspond to that globe's position. Choose from the following. So we need to know which dates fall in which seasons. Summer would be June 21st. December 21st would be winter. March 21st would be spring. And September 23rd would be fall. Next part, label the part of the Earth's revolution on the northern hemisphere. Diagram where the orbit is in aphelion and perihelion. And this is the furthest part and the closest part. So when we talk about how far away we are from the sun, and I believe it went over this in one of your lesson packets, we are actually at aphelion on July 3rd, which would be about here. And that is the one that is the furthest away. And we are at perihelion on January 2nd, which would be about here. And that is the closest we are to the sun. So many times I hear students say, we have the seasons because we change how far away we are from the sun. No, that's not true. If you look at this, perihelion, this is the point where we are the closest. And we're the closest to the sun in January. So the seasons must be caused by something else. It's caused by the tilt. Okay, label on the correct globe, the northern hemisphere diagram. We want to label our 4 special days that we know. Summer solstice, of course, would be on June 21st. Signifies the start of summer. It's also the longest day of the year. Winter solstice would be on December 21st. Signifies the official start of winter. It's also the shortest day of the year. Then we have the spring or the vernal equinox, which would be on March 21st. That is when day and night are of equal length. And the autumnal equinox would have to be September. When day and night are of equal length. Okay, that finishes the northern hemisphere picture. Pause here if you need to write this down. I will be erasing to go to the next picture. Now we're doing the diagram for the southern hemisphere. Most of the things that we will label will be the same. So in fact, you could probably do this picture pretty well on your own. Label the equator, label the Tropic of Cancer, label the Tropic of Capricorn. We're going to do that on all of our pictures. Next, label the Arctic Circle and the Antarctic Circle on each of your pictures. Next, color the circle of illumination yellow. Again, I'm using red because that's what I have on the smartboard. Circle of illumination is what is lit up by the sun. Place an X at the point of the most direct rays. Remember, this one is behind. Label each season that the southern hemisphere would be in at that point. And now you got to think about the southern hemisphere. This one is going to seem a little bit opposite to you. The southern hemisphere down here is tilted away from the sun, so that would be their winter picture. The southern hemisphere over here, oops, colored the wrong one. Southern hemisphere over here would be this picture, tilted towards the sun, so this is their summer. And again, look at the arrows when you go from winter to summer. Winter to summer, season in the middle is spring. And that makes the last one there fall. Label the date that corresponds to that globe's position. Be careful with this one. You need to remember that the southern hemisphere is opposite of us in seasons, but they still operate on the same calendar. So June 21st is in the winter for them. September 23rd is the spring. December 21st is in their summer. March 21st is in their fall. And one thing that I forgot to point out on the other page was if you look at the North and the South Pole, one thing that's interesting about that is you look at the North Pole here where it's tilted towards the sun. Do they ever have nighttime, truly? No, it's daylight all the time because even as the Earth rotates, even as it spins around, this point right here at the North Pole is always on the lighted side. If you look at the winter one, or our winter, because we're talking about the North Pole briefly, we're tilted away here. Even as the Earth rotates, this one is always in the dark. It's always on the dark side. So even as the Earth spins once every day, the North Pole doesn't get any daylight during the winter. Same would be true for the South Pole, but of course, seasons would be switched according to their dates. Okay, back to the list. Label the aphelion and the perihelion. We did that on the previous picture. Oops, spelled that wrong. Aphelion is on July 3rd. Perihelion is on January 2nd. And then label these points on the correct globe. We need to label our special days. So their winter solstice would be June 21st. Which makes their summer solstice December 21st. Their autumnal equinox is in March. and their spring equinox is in September. Okay, that will do it for today. This is for a stamp.